Okay, this video is for the 3 15-minute FRQs that were part of FRQ 4. As I've done with the other videos, I'm going to walk through kind of like my thought process as I walk through the problems. I will also show you where the points are. And then as always, if you have any questions, whether it's questions about partial credit, like you don't know if you would have earned partial credit for your work, or a problem with the calculator, or whatever your question is or your hang-up is, if it doesn't get addressed through this video, send me an email, take pictures of anything you want me to take a look at. I'm here to support you to the best of my ability. I just need you to communicate with me. So let me know if there's anything not answered in this video. Okay, so these 3 FRQs come from different years. This first one is from 2015. It is a calculator one. So you would have your calculator to aid you for this. They tell you that f and g are 2 functions given, and they actually give you a picture already of f of g. Now, with this one, I myself don't, initially speaking, know whether the top function here or the bottom function is my f versus my g. And because it's a calculator one, I don't need to. I can take my 2 functions, graph them, and see which one is this kind of almost trigonometric looking one, and which one is the kind of quadratic looking one. And I can identify my f and g that way. If this was a non-calculator one, which these particular functions wouldn't be, but if you did have a non-calculator one with maybe obviously some easier functions to check, and you were given a picture like this, you could take values of x and y, and maybe take like x equals 0 in this case, and you could plug it into your functions to see which one gives you 2. Now obviously for these 2, they're both going to give you 2. That's where they intersect. Right, but you could test values to start helping you figure out, if it was a non-calculator one, which function was which. Again, I'm not going to do that because I have my calculator. And so when I graph f and g here, I get my 2 values, which is that f is this function here, and g is this function here. And let me go ahead and put that on the screen so we can see what I'm looking at. Plus e to the x squared minus 2x, and x to the 4th minus 6.5x squared plus 6x plus 2. Okay, so there's my f of x function, which is that kind of more quadratic-y looking one, and my g of x function, which is the more kind of trigonometric looking one. Right, so g of x is this guy here, and then f of x is the quadratic-y looking one. Okay, R and S are the 2 regions enclosed by the graphs. I can see them here. Here's R, here's S. First things first, find the sum, so addition of the areas, we're talking 6.1, of regions R and S. Okay, so in 6.1 we looked at how to find areas. Area is, for the most part, in terms of x. There are times where you can turn it into y if you want, but you never have to. You can always leave it in terms of x. So I'm going to leave it in terms of x because I don't really want to change those functions. So first region here, my R region, goes from 0 to that intersection point, whatever that intersection point is. Okay, so then you could take your calculator, do second calc, intersection, first curve, second curve. That intersection looks like it's around 1, and I find out that that intersection is at 1.0328319. Okay, and in that region, upper minus lower. My upper in this case was the g of x function. My lower in this case was the f of x function. And then I'm going to add that to my next region, which goes from that intersection, that 1.0328319, the rest of the way to 2. In this case, my upper minus lower, my upper is the f of x function, minus my lower, which is the g of x. Okay? And so then you would take your calculator, you'd plug all of that in, one piece at a time, and when you plug that in, you should get 2.0043456. Remember, you only have to be accurate to 3 decimal places, so you could write it as just 2.004. Okay? This one was worth 4 possible points. Okay? Your points are as follows. First one are for your limits, your 0 to the intersection, your intersection to 2. And so 1 came from, I'll put it up here, 1 came from the limits. Okay? 2 came from your integrands, the g of x minus f of x with this particular set of limits, and the f of x minus g of x for that particular set of limits. And then the last one came from your answer. And then same thing as we talked about in prior videos, if you make an error at some point, but the rest of your work reflects your error, you can still earn those points, right? So for example, say you got the g of x minus f of x and the f of x minus g of x correct. Okay, great, you got your 2 points. But say you, I don't know, in calculating your intersections, maybe you accidentally called this one 4 instead of 2 because you looked at the y coordinate instead of the x coordinate. Or I don't know, something like that, right? So if you've made an error here, yeah, so you lost your limit point, bummer. But if you plug your integrals in, so maybe you put 4 here on accident, right? So you lost your limit point. But if you plug in the integral from here to 4, and obviously you're going to get a different answer. You're not going to get 2.004. You're going to get something else. You still get your answer point even though your answer is quote unquote wrong, right? Because your answer is founded in your work, okay? As long as you haven't oversimplified the problem, you will continue to get points. It's where I'm going to say again, with your free response, you want to make sure you don't leave anything blank. Try your best to ascertain, is this a derivative maybe, or an integral, or plugging in, but do something. Move on. Found it in the problem. Don't just make up numbers, right? Work with what you're given, but do something. Move on. You could potentially still earn partial credit down the line through the problem, even if you've made an error at the beginning, right? So don't leave it blank. Okay, B. B says region S is the base of a solid whose cross section, so we're talking 6.3 here, perpendicular to the x-axis, so we're in terms of x, are squares, so we're talking s squared. Find the volume of the solid. Okay, so again, 6.3 is where we're looking. Okay, in terms of x, woohoo, it's just region S that we're doing for this one, so we're just going to be doing from the 1.0328319 to 2. And my region S here, the cross sections are squares, so my upper minus my lower, my f of x minus g of x is getting plugged into the squares formula. And so this would be f of x minus g of x squared. Oh, that was off the screen. I apologize. Okay. Here, let me do a quick little walkthrough. I didn't realize that was off the screen real fast. Sorry. So I read through the problem, wrote down 6.3 for cross sections, x-axis squares are s squared, find the volume of the solid. Okay, and then I set up my problem, x-axis, so we're in terms of x, just region S, so we're only using this guy here, my region S bit. And that upper minus my lower, my f of x minus my g of x, is getting plugged into my s squared formula here, f of x minus g of x squared. Okay. A reminder, with equilateral triangles, it's root 3 over 4s squared. That's a formula that people a lot of times forget. And with semicircles, that you have to divide your diameter, which is what your upper minus your lower is, by 2 to turn it into the radius that you need for 1/2 pi r squared. Okay? If you take that and you plug that into your calculator, you should get an answer of 1.2831633. Again, you only need 3 decimal places, so you could just write 1.283. Okay, this one was worth 3 points total. First one, or first two, I should say, were for your integrand. So knowing that it's the f of x minus g of x, and knowing that it needs to be squared, because it's a square that you're plugging into. So 2 points come from that integrand. And then 1 point comes from your answer. Again, same thing. If you have made an error before, but you plug that in, you will still get your points. So for example, if up here you identified your limit wrong and you went to 4, notice there was no point down here for limits. You've already lost the limit point in part A. You wouldn't get double docked, right? You're still using the limits that you had identified for region S here. If you set this all up, you still get your points, right? Keep going. Move on. Don't leave anything blank. Okay? Okay, C was our last one. Says let H be the vertical distance between graphs of F and G in region S. So H is the vertical, H of X is the vertical distance between F and G in region S. So here's region S. That vertical distance was, again, F of X minus G of X. Right, the same thing we've used in both parts A and part B. So F of X minus G of X. Find the rate, so a derivative, at which H changes with respect to X when X equals 1.8. Okay, so we need to take a derivative here. Okay, so my derivative of H is going to be the derivative of F minus the derivative of G. And so you have two options here. One, it is a calculator one, and so you could use your calculator to help you figure out the derivative of 1.8. I will do that very shortly. For those who prefer to actually take derivatives, you could actually take the derivative of F up here, so that derivative would be 0 plus 1 plus e to the x squared minus 2x times 2x minus 2, the u prime. And then your g of x function would be 4x cubed minus 13x plus 6 plus 0. Okay? And so you would have those down here. Make sure that with the g of x, if you are taking the derivative by hand, that is in parentheses because it's behind a minus. Or you would have to automatically distribute the negative in. For those who are using your calculator, we're obviously just going to write it like this because I'm not going to be taking it by hand. And so then plugging in my 1.8, those who did their derivatives by hand, you then would be putting 1.8 into each of your x spots. And then remember, you don't have to simplify anything. So if you took your derivative by hand, plug 1.8 into each of the x's, right? So this was 1 plus e to the x squared minus 2x times 2x minus 2 for its derivative. If you put 1.8 into each of those x spots, then don't simplify, leave it alone. You've got your answer. For those who are planning to use their calculator, okay, so you would do second calc, derivative. We want to find the derivative of f first. Well, f is my first function, that blue one there, right? So my cursor's on that guy. And so I'm going to type in the derivative at 1.8. They tell me the derivative is 2.1162837. And then I'd repeat that process, second calc, derivative. Now I want the other function, so I'm going to go ahead and hit down to get me to the other function. I'm going to type 1.8. It's telling me that that function's derivative is 5.9280072. Okay, and then you don't have to simplify, so leave it there. If you do simplify, you get negative 3.811. Or negative 3.812 if you were to round, but I would write negative 3.811 just because I always truncate. But you don't have to. Leave it alone. Okay, you're good to go. This one was worth 2 points. First point was for the h prime, considering h prime, and second point was for your answer. Okay? Same rules for partial credit. Okay, next up we have calculator, another calculator one, 2019, so this was just last year. we have the velocity of a particle p moving along the x-axis is given by the differentiable function v sub p, where v sub p of t is measured in meters per hour and t is measured in hours. Okay, and we see all that reflected in our table, right? Hours, meters per hour. Again, I know I'm working with velocity, confirmed by my units here. Selected values of v sub p of t are shown in the table to the right. This actually should be above. Again, I reformatted the page as I was creating your homework, trying to give you enough space to write. Particle P is at the origin at time t equals 0, so they give me a starting position. So that always gives me a kind of desired position formula feel, as I've talked about in the past. So the minute I read that I've been given a position, I always set up my desired position formula. My given position is the origin, which is 0. The time corresponding to that position is also 0. And then this will be the desired time if they ever ask me to actually find position. Okay? Okay, so first up we have part A, justify why there must be at least one time t between 0.3 and 2.8 where v prime or v sub p prime of t, the acceleration of particle p, equals 0 meters per hour or meters per hour squared. Okay? So we've talked about this a number of times over almost all of our FRQ videos at this point, but when we are asked to guarantee that a derivative exists, that's MVT. Okay, so I'm guaranteeing a derivative exists is MVT. That's out of 3.2 in your notes. Okay, and so there are a couple of things we have to guarantee. First off, we do need to make sure that we state that we're differentiable and continuous, which in this case we are. It tells us, right, velocity, it's a differentiable function. So therefore I am good to go. I'm differentiable and continuous. And then the second thing that we have to guarantee is that there is a place where my f of b minus f of a over b minus a equals what I'm trying to guarantee. In this case, I'm trying to guarantee 0. Okay? And so I made the recommendation several times that I always recommend starting with the two values given. So in this case, I'd be doing my f of b, which is 2.8, minus my f of a, the 0.3, over b minus a. And in this particular instance, at 2.8, my v sub p is 55. At 0.3, it is also 55 over 2.8 minus 0.3, which is 2.5. And 55 minus 55 is 0. Okay, and so in this particular case, my two endpoints happen to actually fulfill MVT. If they didn't, then I'd start testing other values because it could be something in between them. So if 0.3 didn't work, well, maybe I'd try 1.7 and 2.8. Or 0.3 and 1.7. Or if I had other values to test, I'd test those as well until you find where that slope that you're trying to guarantee, remember this is slope, change in y over change in x, till you find the slope you're trying to guarantee. In this case, we found it at our endpoints. And so then we're good to go ahead and express that. So justify why there must be at least one time t on 0.3 to 2.8 such that v sub p prime of t equals 0 because whoops, I don't want to say by, because how do I want to say this? Because, well, let's just state MVT. Because v sub p of t is differentiable, and therefore continuous. And v sub p of 2.8 minus v sub p of 0.3 over 2.8 minus 0.3 equals 0. Okay? Couldn't figure out how to state the name MVT for a second there. So if you could figure out how to work the name of mean value theorem into your explanation, that's great. But you don't actually have to, for the record. If you can articulate what MVT requires, which is differentiable and continuous, and that there's an f of b minus f of a over b minus a, then you are good to go. Okay? Okay, this particular one was worth 2 points. First point was for finding where that 0 could potentially exist, and the second one was for your justification using MVT. Again, you did not have to write the name MVT, but you did need to state that you are differentiable and continuous, and you did need to state that where the f of b minus f of a over b minus a existed. Okay? Okay. Part B we have use a trapezoidal sum with the 3 subintervals 0 to 0.3, 0.3 to 1.7, and 1.7 to 2.8 to approximate the value of this integral. Okay, so this integral 0 to 2.8 of v sub p of t dt is approximately, we're doing a trapezoidal sum, so this is 1/2. Your change in this first subinterval, 0 to 0.3, is 0.3. And then if it was a left hand, you'd do the left value, 0. If it was a right hand, you'd do the right value, 55. It's a trapezoidal, so we do both, 55 and 0. And then you repeat that process, 1/2. This change here is a change of 1.4. And we use both the 55 and the negative 29. And we do leave this one as negative 29 because there's no absolute value bars here. But if we did have absolute value bars, then you'd want to make sure that was positive. And then last one, 1/2 change. 1.7 to 2.8 is 1.1. And we use both the negative 29 and the 55. And then this was a free response, so again, you don't have to simplify. You're good to go. Now it is a calculator one, so if you wanted to plug it into your calculator, you could. Again, it's a waste of time when you don't have to simplify, right? But if you did take the time and plugged it into your calculator, you would get a value of 40.75. Okay? Unfortunately, this one was only worth 1 point this year, so you did have to get it correct. I would say a lot of times this is worth 2 or 3 points, but this year happened to only be worth 1. Okay? Okay. C says a second particle, Q, also moves along the x-axis so that its velocity between 0 and 4 is given by this function here, meters per hour. Okay? Find the time interval during which the velocity of particle Q is at least 60. So we need to figure out where are we at least 60 meters per hour. And then find the distance traveled by particle Q during that time interval, right? And so we know we're going to be doing some total distance. I don't know, again, what my bounds are, but it's going to be the absolute value of v sub q of t. Okay, that's total distance formula. Okay? Okay, so quick strategy here for this one, which again, I don't know that you'll have a problem exactly like this one this year, but it's a good thing to keep in mind. What makes C, I would say, especially challenging is that statement that we need to find a time interval where particle Q is at least 60 meters per hour. Okay? Strategy. Okay, if you find yourself in a situation like this one where you're like, well, I know that I'm supposed to set up an integral of the absolute value. I know how to plug that into my calculator and get an answer. I just don't know how to get the bounds, right? Well, again, do something. You can't make up numbers. You can't just be like, I'm doing 1 to 3, right? Like you need to somehow try to figure out what those values would be, but keep going. Don't give up. right? Try to figure out what those numbers are. Found it in the problem. Get some values by taking a derivative, taking an integral, graphing some things, finding intersections, finding zeros. Like, do something to see if you can figure out what numbers they might be. Put those numbers here. Plug that into your calculator, get your answer. You can still get points even if you get stuck on the first step of the problem. As long as, again, you make honest mathematical attempts to figure out your answer. You can't oversimplify the problem, right? It has to be founded in your work, okay? So, trying to figure out where that is. Where is my velocity, my v sub q of t, at least 60? It could be more than 60, right? But it needs to be at least 60. So if you wanted to write that as an inequality, you could. It'd be greater than or equal to 60, but you don't actually have to do that. We just need to figure out where those values are. Where is my v sub q of t at least 60? Okay? So there's a couple of different ways of doing that. First up, you could graph these two functions. So 45 root t cosine of 0.063 t squared. Make sure you're in radians, especially for my physics students, right? Make sure you're in radians. And you could graph 60. Now, if you're going to do this way, make sure your window includes 60. Right? So we're going to go up here. We're going to maybe go to 65. There's my v sub q of t. That's graphing. There's my 60. And so I can see that my v sub q of t is at least 60 from that intersection where it equals 60 all the way to that intersection where it equals 60 again. Outside of those two endpoints, okay, my v sub q of t, my velocity, isn't at least 60. It's less than 60. And so it's everywhere between those two intersections. And so you could do second calc intersect. This first one looks at like it's maybe at around 2. Find out that that one's at 1.8661815. Okay, and then I could do it again, second calc, intersection, first curve, second curve, the next one looks like it's around 4. Find out it's at 3.5191744. Okay, and so those are your values of t. Other way you could do it if you wanted, if you didn't want to have to mess with your window, is here where we've set up some sort of equation. You could subtract the 60 over. Coming back over here, I subtracted the 60 over. And then it wouldn't matter what your window equaled necessarily, because if you subtract 60 over, what you get is v sub q of t minus 60 equals 0. And so then all you have to be able to see is the x-axis. Where do we equal 0? It'll graph that. And so then if you calculate your zeros, left bound 1, right bound 2, you get the same two values, 1.8661815, and then same thing over here. Oops. 3.5191744. Okay, so you could calc zeros instead if you wanted. Okay, and so those are your bounds. Okay, and then you take that, you plug it into your calculator, and you should get about 106.10875 as your total distance there. Okay. Okay, this one was worth 3 points. 1 was for accurately identifying the interval. 1 was for your definite integral, doing the absolute value and all that, knowing what total distance is, and 1 came from your answer. And again, if you messed up here, as long as you didn't oversimplify, you'd lose the point for the interval, but if you took that interval plugged it into your definite integral and got an answer, you can still earn some more of the other points as long as you haven't oversimplified the problem. And so again, if there are questions on that, send them my way. More than happy to check your partial credit if you're not sure. Okay, part D says at time t equals 0, the particle is at position x equals -90. Okay, so I've got another little desired position set up here, -90 plus, so that's my given position, given time is 0, desired time is going to be t, v sub q. Using the result from part B, so this guy up here, and the function v sub q from part C, approximate the distance between particles p and q at time t equals 2.8. Okay, so I need to know where those two particles are so I can figure out what's the distance between them. Okay, so my position of my particle at, my position at time t equals 2.8 for particle q, let's do that. So particle q has position at t equals 2.8 of, and so the desired position formula would be -90 plus the integral from 0 to 2.8 of my v sub q of t. And so then I take that and I'd plug it into my calculator. Okay. And you'd use your v sub q formula up here, the 45 root t. And when you plug that in, you should get about 45.937653. Okay? Particle P has position at t equals 2.8 of, and particle P's desired position formula was this one up here, 0 plus, etc. So 0 plus the integral from 0 to 2.8 of v sub p of t dt, which, that's why they said use the part in part B. We figured out what that integral from 0 to 2.8 of v sub p of t was, or we approximated it. It was this approximation here. And so you could rewrite this entire thing, or you could take a moment and plug this into your calculator now and get the 40.75, or you could set this equal to some variable that you haven't used yet. We haven't used a anywhere. And then you could just say equals a, or 0 plus a, which is a. And so then the distance between the two of them, I'll go ahead and write the 40.75 as well, because I'll admit I did plug it into my calculator when I did it, the 40.75. The distance between the two of them is the 45.937653 minus 40.75. And again, you don't have to simplify, so you can leave it there, or you could plug it in and get its value, which is about 5.187. Okay? Okay, this one was also worth 3 points. First point came from taking the integral from 0 to 2.8 of your v sub q of t. So even if you were sitting there, this is what I was talking about, where it's like, do something related to the problem. Even if you were sitting there going, I'm not really sure how to find the distance between the two of them, but I know that the integral of velocity gives me position. Well, so maybe you just take the integral of the v sub q of t and you write that down and you hope to snag a point. And this year you would have. You would have gotten 1 point just for doing the integral piece. You got a second point for then including the -90, being able to find the position of particle Q. And then your third point came from your final answer. Okay? Okay, last 15-minute one here came out of 2017. This one was a non-calculator one. Okay, we have a function f of x. We have a table showing us values of g and g prime. And then we have a graph of h consisting of 5 line segments, which is also shown, graph of h. Okay, A says find the slope of the line tangent to the graph of f at x equals pi. This comes out of Unit 2, slope of the line tangent, aka derivative. That's what a derivative is. It is a slope. It is a rate. It's asking us to find the derivative of f at x equals pi. Okay, so derivative of f, here's my f of x, derivative of f is, derivative cosine is negative sine, leave the guts alone, times the derivative of the guts. Derivative e to the u is e to the u times u prime, derivative of sine is cosine x. Okay, and then at pi, we have negative sine 2 pi times 2 plus e to the sine pi times cosine pi. And then don't simplify. It's a waste of time. You don't have to simplify. That's my answer. No reason to go any further than that. Okay? If you did simplify, this should be, so sine of 2 pi is 0. So all of this should be 0 here. Cosine of pi is negative 1. Sine of pi is 0, so this would be e to the 0 or 1 times negative 1, which is negative 1. So if you did simplify, you would have to get negative 1. But if you simplified wrong, you just would have lost your answer point. So don't simplify. There's no reason. It's a waste of time, and you might lose one of your points. Okay, this one was worth 2 for finding that derivative. Okay, B says, let k be the function defined by that. Find k prime of pi. Okay, so k prime. So when actually, technically speaking, would come out of 2.4 if you want to know exactly where in the notes to look, because this is chain rule in here. Okay, derivative of the outside, we've got our h prime. Leave the guts alone. Times the derivative of the guts. Derivative of f is f prime. And so then plugging in our pi, we have f of pi times f prime of pi. Okay, which is h prime of f of pi. So plugging pi into my f here, we have cosine of 2 pi, which is 1, plus e to the sine of pi, or e to the 0, which is also 1. 1 plus 1 is 2. And then f prime of pi, you have a choice to make. You can either write times negative 1, or if you didn't simplify to negative 1, you'd write this out, times negative sine of 2 pi times 2 plus e to the sine pi times cosine pi. Or you could do what we talked about in the last problem, which is you could set this equal to like a. Just make sure you use a variable, a letter that hasn't been used yet. You could set it equal to a, so like equals a, and then you could call this a back here. And you could call it a for the rest of the problem. You would never have to actually plug this back in if you have defined what a represents. Right? So it's a time-saving strategy. Okay? And then h prime of 2, here's my graph of h. H of 2 is right here. H prime of 2 is the slope at that point, which this line here is down 1 over 3, so it has a slope of negative 1/3. Oops, I wrote x and pi. Okay. If you were to simplify this all the way, this would simplify to 1/3. Okay. This one was also worth 2 points for finding that derivative. Part C. Oh, sorry, the 2 points up here, 1 for finding the derivative, 1 for accurately plugging in pi and solving. Right, so 2 points, 1 for finding the derivative, the chain rule bit, and 1 for plugging in pi and solving for it. Okay. C, we have let m be the function defined by this. Find m prime of 2. Okay, so we're going to go ahead and find m prime of x. Okay, this is product rule, 2 things multiplied together, and then we've got a chain rule element here. We have 1, which is g of negative 2x, d2, h prime of x, plus 2, h of x, d1, g prime of negative 2x times negative 2. And then plugging in 2 in this case, m prime of 2 equals g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. And so then pulling this out, g of negative 4 is 5. H prime of 2, slope at 2, we actually found that in the prior one as well, was negative 1/3. Because remember, here's my h graph at 2, this was down 1 over 3. That's what h prime is, it's a slope, it's a derivative. So this would be negative 1/3. Plus h of 2, what is my y value there? Well, at x equals 0, my y value is 0. At x equals 1, my y value is negative 1. And so at each of these spots, it went down 1/3, right? This would be 0, negative 1/3, negative 2/3, negative 3/3, or negative 1. So my y value here is negative 2/3. G prime of negative 4 is negative 1. And then our negative 2 at the back. And again, you don't have to simplify. If you did simplify, this would be negative 5/3 minus 4/3, which is negative 9/3, or negative 3. Okay, this one was worth 3 points. 2 for the derivative, the product rule and chain rule component, right? This derivative, 2 points there, and 1 point for actually plugging in 2 and solving correctly. Okay, last one, part D we have, is there a number C in the closed interval negative 5 to negative 3 such that g prime of C equals negative 4? Again, we've talked about this a number of times, starting with the beginning of this video, or I should say the beginning of the problem before this one, the 2019 table one, which is that if you are looking to guarantee that a slope exists, that is MVT. Okay, so MVT states first that you have to be differentiable and continuous on that interval. Well, this is G. G is differentiable, and so we are good to go there. And then you have to find an f of b minus f of a over b minus a that equals what you're trying to guarantee, which in this case is negative 4. I always recommend starting with the endpoints provided. So f of b minus f of a over b minus a. If those don't give me negative 4, then I'm going to go ahead and maybe try negative 5 and negative 4, or negative 4 and negative 3. Anything else that's in this interval, trying to guarantee that that slope exists. Okay, well, g of negative 3 here, if you look up at your table, g of negative 3 is 2. And g of negative 5 is 10. Over negative 3 plus 5, which is negative 8 over 2, or negative 4. And so therefore, does it exist? Yes, there is a number C on negative 5 to negative 3, such that g prime of C equals negative 4 because, and then you can articulate MVT, because G is differentiable and therefore continuous, and I have an f of b minus f of a over b minus a. That equals what I'm trying to guarantee, -4. Okay? That one was worth 2 points. 1 point for finding the g of -3 minus g of -5 bit, and 1 point for your answer articulating MVT, right? Meaning that you had to state that you were differentiable and continuous, and you had to state that you had an f of b minus f of a over b minus a. Okay, so those are your 3 15-minute FRQs from FRQ 4.